A circuit breaker is a device that detects current fault conditions and then completely interrupts current flow. For operations and safety reasons, it is important for operators to understand how circuit breakers work. These are the objectives for this course. Circuit breakers are an absolutely essential part of any electrical system. It is important to understand that when used in conjunction with proper grounding, circuit breakers can safeguard against electrocution and protect appliances, wiring, and property against fire hazards and other damage resulting from abnormal current flow, short circuits, overloading, and heat buildup. Unlike fuses, which must be replaced when they open, a circuit breaker can be reset once the overcurrent condition has been corrected. There are three major purposes for circuit breakers. The first purpose is to break or open a circuit for protection and provide normal switching without causing damage to the circuit or the circuit breaker. The second purpose is for isolation purposes during maintenance. The third purpose, under unique circumstances and circuit design, is to act as a starter for larger motors. Air circuit breakers are breakers where the interruption of breaker contacts takes place in an air environment. Oil circuit breakers use oil to quench the arc when the breaker contacts open. A low voltage circuit breaker is suited for circuits rated at 600 volts or lower. One of the most commonly used low voltage air circuit breakers is the molded case circuit breaker. The available frame sizes are 100, 225, 400, 600, 800, and 2000 amps. The continuous current rating of a breaker is governed by the trip element rating. The range of voltage available is from 120 to 600 volts, and interrupting capacity ranges as high as 100,000 amps. Low voltage circuit breakers typically have main and arcing contacts, an arc extinguisher, an operating mechanism, a tripping mechanism, and terminal connectors. The main contacts are designed to carry operating load current of an electrical system. Main contacts consist of movable contacts and stationary contacts. In a three-phase circuit breaker, there are 3 stationary contacts and 3 movable contacts, a set for each phase. The stationary contacts are mounted on a common base of insulation material. The movable contacts are mechanically joined to assure that all 3 sets move together. Each set of contacts has arc chutes to minimize the duration and intensity of an arc. The arc chutes stretch, cool, and extinguish the arc across the main or arcing contacts when making and breaking a circuit. When the arc is drawn into the arc chute, it is divided into small segments and quenched. This action extinguishes the arc rapidly, which minimizes the chance of a fire and also minimizes damage to the breaker contacts. The operating mechanism assures a fast, snapping closing action, regardless of the speed at which the closing handle is operated. The breaker operating handle is attached to the operating mechanism. The mechanism is designed to have a mechanical trip-free feature to prevent holding the breaker shut during an electrical fault condition. The tripping mechanism consists of a trip bar or shunt tripping device, depending on the breaker's service. The trip bar allows local tripping of the breaker. The trips associated with low voltage air circuit breakers. Terminal connections are located on the rear of the circuit breaker and provide a mechanical connection of the breaker to the electrical bus. The 480 volt air circuit breaker has 3 racking positions to indicate the physical position of the breaker. In this position, the breaker is physically attached to all the connections and is ready for operation. The circuit breaker has control power, incoming primary power, outgoing or load power, and ground connections, all connected between the breaker and the cubicle buses. This shows the breaker ready for maintenance and is not electrically connected to control power, primary power buses, or ground. In this position, the circuit breaker is lined up for operational testing. Only the control power and ground are hooked up. The breaker can be cycled as necessary for testing, but it is not attached to the primary power buses. A protective relay is a sensing device designed to detect operating conditions on an electric circuit. When the relay senses the abnormal condition, the relay activates and opens the circuit breaker, disconnecting the defective equipment or circuit as quickly as possible. Some of the common relays and their functions. Commercial and industrial systems use very large air circuit breakers that have current ratings as high as 4,000 amps and interrupting ratings as high as 150,000 amps. Most of these large air circuit breakers are electrically operated, stored energy circuit breakers, where energy is stored by compressing large powerful coil springs that are attached to the contact assembly of a circuit breaker. Once compressed, the latch may be operated to release the springs, and spring pressure will close the circuit breaker.